Hey everybody, Mr. Covey here, your favorite PSGH teacher, and this is section 1.9, and we're going to be talking about probability. So first, you have some familiarity with probability, hopefully. Probability, to calculate it's really the total winners over the total possibilities is the way I like to think about it. So we're going to write that as a fraction. Total winners divided by all of the possibilities, the total number of possibilities. Okay, and probabilities are between 0 and 1, 0 being 0%, 1 being 100% chance of that happening, and it can exactly equal either of those amounts. So far, all the probability you've done, or at least most of it, has been discrete. That means countable is the fancy math word for that. And what that means is you calculated it like we were talking about up here. You found the total number of things that fit whatever probability you were looking for, and you divided by the total number of possibilities. Some of the problems we're going to look at today are going to be geometric probability problems, meaning you can't use this approach above because they're non-countable. Okay, and we'll talk about exactly what that means. However, they are measurable. And again, we will clarify this in a minute. Okay, so let's start looking at some problems here. These are some discrete probability problems. So it says one of these 6 angles we see over here is selected at random. What's the probability that it's acute? That angle is acute. Well, our total possibilities is 6. If we look over here, we have 2 of those angles are acute, so the probability is 2 out of 6. We can simplify that to 1/3. The probability that is obtuse, 3 of the angles are obtuse out of our total of 6. We can simplify that to 1/2. Probability that it is right, only 1 of the angles is right, so that's just 1/6. The probability that it is a straight angle, none of the angles are straight. Probability is 0. There is no chance that you'd pick a straight angle. And the probability that if you picked one of the 6 angles that you'd pick an angle, it's kind of a weird question, but our answer would just be 1. Of course you're going to pick an angle. All of those count as an angle. Okay, let's look at a couple of little bit trickier ones. So here it says 2 of the 6 angles are selected at random, and not replaced means after you pick that first angle, you don't put it back. So you pick an angle, and then from what's left, you pick another angle. All right, so let's look at some of these. So the probability that they're both acute, well, the probability that the first one's acute is 1 out of 3 because it's 2/6, like we said before. And then after that, we have to pick another acute angle. Well, if we've already picked one of the 2 acute angles, there's only 1 left. And since we've already picked an angle, there's only 5 angles left to choose from. We have the probability of both of these things. Since we want them both to happen, we multiply those probabilities to give us the overall probability that that happens as 1 out of 15. So the probability of picking acute and acute is 1 out of 15. Okay? This next one, we got to be a little bit careful here. It says the probability of when you pick the 2 angles that one's right and one's obtuse. So let's kind of go above, similar to how we did it above. So the probability that you pick a right angle the first time is 1 out of 6, because just one of them is. Then after you pick that right angle, there's only 5 angles left, and 3 of them are obtuse. Multiply those. You get 3/30, which is 1/10. But wait, that's just the probability that you pick a right and then an obtuse angle. If it's asking us the probability of picking a right and obtuse angle, we could also pick those angles in the opposite order. So this is the probability of right followed by obtuse. We need the probability of obtuse followed by right, because if we're just asking the probability of picking one of each, we could pick it in either order. Okay, so let's slide over here. What's the probability of picking obtuse and then right? Well, 3 of the 6 are obtuse. Then after you pick one of the obtuse, there's 5 angles left, and one of them is right. So then there's a 3/30 or 1/10 probability that you pick them in that order. So then if we want to find the overall probability of right and obtuse, you take those two probabilities and add them together. So our total probability would be 2/10, in other words, 1/5. Okay. And this last one is similar. So we want to know the probability of obtuse and acute. So we could pick obtuse then acute or acute then obtuse. So we got to find both of those probabilities. Let's do obtuse acute first. So obtuse, then there's 5 left. 2 of them are acute, so that would be a 6 out of 30 chance. We picked an acute first, there's 2 of those. And then there'd be 5 angles left, 3 of which would be obtuse. So there'd be a 6 out of 30 chance we'd pick it in that order. So overall there'd be a 12 out of 30 chance, or a 6/15 probability, that we'd pick an obtuse and an acute angle. Okay. Next problem is very similar, only difference is this replaced situation. So now after you pick the angle, you put it back in and we kind of reset everything. So the probability of picking acute and then acute, a probability of picking acute is 2 out of 6. But then after we pick that acute angle, we put it right back in. So the probability of picking it a second time, or picking a second acute angle, is 2 out of 6 as well. So it's 4 out of 36, which is a 9th. Okay, so just be careful about that replaced versus not replaced. Okay, this next problem says, if a roach is stuck in the box that's 10 by 15 inches, so in this whole box, what is the probability that if it stops, it will stop in the red region? And then it says, what is the probability that it will not stop in the red region? Okay, this is a geometric probability problem because your total possibilities isn't a finite number. So like, how many points can you fit in this square? Well, you could start drawing points, but you're going to fit infinitely many points in this square, or in this rectangle where that roach could stop. So trying to think about this as total possibilities as our denominator doesn't really make sense. What we can do is think about the area of the whole rectangle, because that's our total area possibilities. So the way I would think about this is the probability that it stops in the triangle is going to be the area of the triangle, because that's what we want to find the probability of, divided by all of the possibilities. Well, all of the places it could stop is anywhere in the rectangle, so we do the area of the rectangle as our total possibilities. Okay, so it's a little bit different way to think about it than counting like we've been doing. So we do those two calculations. The area of that triangle is 1/2 base times height, 15. The area of the rectangle is 10 times 15, so 150. So then the probability that it would stop in that triangle is 1 out of 10. And it kind of makes sense because 1/10 of the rectangle is the triangle in terms of area. Okay? If it asks us what's the probability of it not stopping in the red region, well, it either stops in the red region or it doesn't. So if there's a 1 out of 10 chance that it stops in the red region, there's a 9 out of 10 chance that it doesn't stop in the red region. So that's our probability that it stops in something that's not just this red region there. Okay, let's look at a couple more like that. Here's a very similar problem. It says we have a circle of radius 14 and the rectangle is 10 by 2. What is the probability of the arrow hitting that purple rectangle? So what we got to do for this one is we got to take probability is, so we got to see the probability that it hits the rectangle divided by the total probability, which is the whole area of the circle. So we're going to do area of the rectangle divided by area of the circle. Area of the rectangle is 10 times 2, which is 20. Area of the circle is pi r squared. It's pi times 14 squared, which is 196 pi. And we can simplify that as 5 divided by 49 pi. It says exact answer, so we should not type that in and get a decimal. Let's just leave it like that. 5 over 49 pi is that probability. Okay? Second part asks us to round to 2 decimal places. If you type that in your calculator and round it, you should get 0.03 is the probability. Write it as a percent, 3.25% with 2 decimal places there. Okay, let's look at one more problem here. It says a point Q is randomly chosen on segment BS. Okay, so we're not talking about area anymore because we're just talking about a segment, but instead of our bottom being total area, it can be total distance. So the total distance from B to S is 9. They want to know the probability that the point we pick is 2 units from S. So in other words, that it's at 9 or more. Well, this is 2. The whole segment's 9, so our probability is 2/9. Similar for this one here, the only difference is it could be 2 in this direction from M or 2 in this direction. So there's actually 4 units of that number line that would be within 2 units of M. And again, there's 9 total units of length that we could possibly be in. Okay? Probability that it's 3 units from B, again, we only have one direction to go here, but it's 3 units out of our total 9. So we can simplify that to 1/3. Okay, and that concludes video 1.9.